Hello engineers, welcome to the new section of the course, and in this particular section we are going to focus upon this particular part, that is a current source and its applications as well. Application part we are going to see in the upcoming video, so don't worry about that. So as of now in this particular video we are just going to focus upon what exactly is a current source and why exactly it is very important, why it becomes very important to learn this particular concept, that is current source. Because when we talk about voltage source, we just say that okay, we have one battery, we just need to connect one battery to the circuit, right? That's absolutely fine. But what about current source? Why this particular concept it becomes so important when we focus on analog electronics? So we'll see that. Okay, so let's start the video. So as clearly mentioned over here, a voltage source is readily available in the general electronics store. So let's say if this is my circuit, if I want to connect, let's say 9 volt, if I want to power up with a 9 volt of battery, or maybe 3.3 volts, whatever that voltage might be, what I'll do, I'll just go to the nearby electronics store. I'll just ask to the shopkeeper that give me a 3.3 volt battery or 9 volt depending upon the circuit requirement, and then that guy will actually give you the battery. You will just plug that particular battery to the circuit and the circuit will work, right? Great. What about the current source? Okay, what about the current source? Now again you will say, okay sir, so what we'll do, let's say now assume that okay, for some reason you need to provide a constant current source of 3 ampere to your circuit. What will you do? So now again you will assume that okay, what we'll do, again same scenario, if we have this particular circuit, let's say if we want 3 ampere of current okay to be given to this particular circuit, then your approach will be same, right? You will go to the nearby electronic store, you will ask to the shopkeeper, hey please give me a 3 ampere of current source. The moment you say this, the immediate reaction of that particular shopkeeper will be something like this, right? This will be his immediate reaction. This will be his immediate reaction. Why? Because in the reality there isn't such term, that is current source, that is available in the market. You need to design it on your own. Okay, see again I'll just repeat, when we talk about the DC voltage source, it is readily available in the market, let's say 9 volt, 3.3 volts, 2 volts, right? Okay, but when we talk about the current source, it is not readily available into the market. You need to design it on your own. So then it becomes very important, right? That's why it becomes so important. Okay, because you need to calibrate the value of the current source. You need to check whether the circuit you have designed to give a constant current source, whether it is able to generate that particular current source for for let's say 10 days, 20 days. It depends upon your circuit requirement. So you need to focus upon that, right? So that's why this particular concept it becomes so important. Okay, that is current source. I hope this particular part is clear, that why current source is important. Great. Now the next question that arises in your mind, it will be like, okay, we understood that current source is not available in the, it is not readily available into the market. Then how we are going to design it? It may be some tedious circuit, it might be some complex circuit, right? What if I tell you no, you just require one device, right? So basically you see this particular 3 ampere of current source. What you need to do is that you need to just replace this 3 ampere of current source with certain device. Now we don't know what that particular device is, so what you need to do, you just need to connect this particular device to the circuit. Okay, I'm just talking about a simple current source. Okay, I'm not talking about some complex current source. Let's say if I want to generate a 3 ampere of current, I'll take that particular device, I'll just connect it to that particular circuit. Now what that device can be, just pause this particular video and just try to think in your mind that what that particular device can be, which can actually provide me a constant 3 ampere of current. Just pause this video and try to think. Alright, I believe that you all guys have tried your best. Now it's my turn to explain you that what that particular device can be. So that device is very simple analog device, and that is a MOSFET. Okay, so as I had mentioned, current source is made up of using transistor. As we are learning MOSFET, so we'll try designing a simple current source using a MOSFET. Okay, now you might think that how exactly a MOSFET can act as a constant current source. Okay, so well, if you could remember, we have learned the drain source characteristic of MOSFET. I believe that you all guys have understood that particular characteristic in depth, right? So over there we have clearly seen this particular part, that if I maintain this particular condition, that is if VGS is greater than VTH, and if my VDS, if it is greater than equals to VGS minus of VTH, then we all know that this particular MOSFETs operate in what? This particular MOSFET operates in the saturation region. So this particular MOSFET, it operates in the saturation region, right? We all know this particular thing, that this particular MOSFET, it can be operated in the saturation region, provided if we maintain these two conditions, right? Let's say if we are maintaining these two conditions and our MOSFET operates in the saturation region, what can we see over here? We can clearly see that my ID remains constant, not exactly constant. Let's say if I want to operate this particular MOSFET as a current source, so this particular MOSFET won't be able to give exact 3 ampere of current, but it will be able to give, let's say, 2.99 ampere, maybe 3.1 ampere, something like that, but not exactly 3 ampere. But our purpose is being served over here by this particular MOSFET, that is to generate a constant current. Okay. With respect to VDS, of course this current is going to increase, but not drastically, right? Let's say if your current is 3 ampere, if you increase voltage VDS, it may increase to 3.1, maybe 3.2. okay, not like after 3 amperes. Let's say if I increase VDS drastically, the current will increase from 3 to 4, maybe 5 ampere. No, not by that huge amount, but yes, our purpose is being served over here, that is to get a constant current source. So this particular MOSFET, a single MOSFET, is capable of giving a constant current source, or basically it is capable of acting like a current source. I hope this particular part is absolutely clear to you all guys. Great. Okay, so this is what I had mentioned. As we know that a drain current in MOSFET is almost a constant in the saturation region, it hardly depends on VDS, right? So that's why we can say that this particular MOSFET, it can act as a constant current source. I hope this particular part is clear. Okay, so what I'll just quickly revise what all things we saw in this particular session. So what we saw was, in case of a voltage source was readily available in market, but in case of current source, the current source is not readily available into the market. You need to design it on your own. Okay, so yeah, this is what we saw. This particular current source can be designed, this particular current source, it can be designed using a single MOSFET. Okay, and for that you just need to make sure that my MOSFET operates in the saturation region. That means these two conditions, they are being satisfied. Okay, so I really hope that you understood this particular concept. What I'll do, I'll just end this video over here, and in the next video we will just try to see the AC model of MOSFET, and with that we will try to deduce something new with respect to the current source. Okay, so thank you for listening me patiently. I'm ending this video over here. In the next video we'll see the AC model of this particular circuit. Okay, and we'll try to deduce something new out of that with respect to the current source. But till then, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts into the communication section. I will be happy to help you out there. So thank you for listening patiently. Thank you.